Continuing from our discussion of neural networks, this one will take a bit less time, but we'll only simply because we'll go very quickly and very on a high level of what this terminology essentially means, without going into too details on the mathematics. So let's go back. Let's take a quick little recap of what happened. So neural networks, a set of values get inputted, goes through a series of functions known as the weights, bias, linear function, activation function, and then it's outputted, and then it's squeezed by something called softmax, where we can basically get a probability value. But we have to realize something, that this bias value and this weight value specifically has plays a lot of importance in how this value comes out. Initially, I just said, let's just set this weight to 5. But what if that is a misinformation? What if this should be 5? This should be much lower, or this should be much higher. How do we figure this out? This is where something called backpropagation becomes very useful. What we have generally described here is called something called a feed-forward network, where we essentially just keep sequentially moving along the network and then get some result, and then we're just happy with the result. What if we're not happy with the result? That is when we want to go back, tweak these weights that we have little by little, and then check if our output is finally what we want. And how do we do this? To do this, we have to introduce a concept called the loss function. Similar to the activation function, where it has a job. So softmax's job is to squeeze it between 0 and 1. ReLU's job is to make sure anything that's negative gets turned into 0, and anything that's greater than 0 gets to stay the same. The job of loss function is essentially to take anything that's been outputted. So let's say output 1, compare it against the label data, or the actual value. So let's say we have the actual value right here, and then calculate the difference. That's the difference one. And then we keep going back and forth. We keep doing this until we can get this to be as low as possible. If it is 0, then it is often can be misleading because something could be wrong, but this should essentially be as close to 0 as possible. So how does this happen? So this requires a whole chain of partial derivatives, which we're not going to get into, but on a very high level, the way it is done is, if we look at something in high school that we learned, where we have a parabola, and when we take the derivative or the roots of this parabola, we end up somewhere here, or we end up somewhere, let's say like here, essentially that which is referred to as the local minima. Local or global minima, depending on in what context you're reading this. So this right here is the minimum. And if you compare what we just discussed here to here, it is essentially the same. We define a function which can be graphed, and then we want to find the minimum of that function, because what that function outputs, we want that value to be as low as possible. And these are the inputs that we have. For that. And we want to take the derivative of that so that the output could be as low as possible. So this process right here, where we start off some, so this process here, right here, where we try to find the local minimum or the local max or the general minimum, is called backpropagation, where essentially we have something that we start here because that's where our loss value is, and then we slowly start trickling here. We go here, we go here, all the way until we essentially reach somewhere like this. And now a question that might come up is, how do we define how do we go down? Why can't we go down this way, or why can we not just jump all the way down here? Well, that is essentially controlled by something called a learning rate, and the way that can get progressed, that can get essentially more controlled, is doing some sort of hyperparameter tuning. All that it can be further dived into. But let's just quickly summarize what we have right here. We have a neural network where we initially guess what the weights and biases are, and then we use something called a loss function along with gradient descent to basically take what we have guessed, compare it against the actual value, and then we keep going back and forth until we have something that is as low as possible using gradient descent. We essentially try to find the local minimum of that loss function, and then that is when we know that our training is done, and we hope to be happy with our trained neural network. Thank you.